Our first session in the industrial tag is industry keynote on using C and C++ compilers and libraries in safety critical components. For this session, we have Dr. Marcel Beemster, CTO at Solid Stamps, the Netherlands.
Okay, hello everybody. Thank you for inviting me. I'm very honored to be able to present here. I'm going to talk about the safety and security of one of the most important tools that we use for the development of embedded systems, and that is the implementation of the C and C++ programming languages. Now, C and C++ are still the most popular languages in this domain, even though they have some downsides, of course. There are also important reasons why we can still use them and why they're so very popular. Okay, a little bit about my background. I'm the co-founder of Solid Sense. We are based in Amsterdam. Our specialty is the safe use of the C and C++ implementations in mission critical product. And yeah, we started in 2014, and since that, it's been a journey, and every time we talk to customers and we learn new things about the field and new things about the requirements that people have for their C and C++ implementations. So yeah, the slide says we're the go-to place for C and C++ compiler and library testing. And today I want you to tell a little bit more about that path that we're on. Supertest is our validation suite. It is a product, so you can buy it as well. Supertest itself is very old. It is more than 30 years, even 35 years old. The oldest tests are dating back to 1984. So this is a very a product with a very long history, and I'm going to tell you a little bit more about that as well. Now, I just told you that we are the go-to place. Now, actually, you may remember that go-to is actually one of the first statements that was part of this paper by Edgar Ray Dijkstra, where he said, well, maybe for good programming, you should not use the go-to. So that is actually one of the first, I think, generally accepted programming guidelines for programmers. And he wasn't even thinking about safety or compilers yet. Okay, safety, where do we start? This is a picture from Germany, 1869. Clearly this locomotive had some issues. The boiler exploded. And that's maybe not this particular incident, but the Germans in those times became interested in the safety of these industrial machines that were being developed. And still the Germans are today the leading country where the safety standards are verified and certified, and those are very well known everywhere. But that means that there's been 150 years of development in safety. Now, for this particular case, this locomotive, you might think, well, maybe the safety manual should just say, okay, we should add an overpressure valve for this boiler, and then it would not have happened. But that's not how safety guidelines develop. Safety guidelines are really processes. They don't tell you how to do your engineering, but they do tell you to follow certain steps and to think about what you're doing and to document what you're doing. So actually, in this case, adding an overpressure valve would not have helped because what actually happened is that in this locomotive, there was not enough water in the boiler, and that causes the top half of the boiler to overheat. And the steel was not so good yet. Tata Steel was founded maybe 30 years later. The steel of the iron on top of the boiler was not so good, and it started to melt even if there was no overpressure there. So, quality, safety, and security, these are all very related concepts. They all point in the safety, in the same directory. So, good quality you get from good software engineering. And then on top of that, good safety you get from, well, starting with good quality, good software engineering. And on top, you have these functional safety standards in many different areas. That provide you with guidelines, and they also provide you with guidelines for programming and using software and software tools. On top of that, there is security, and think security, it cannot happen without these two previous things. So security should really build on top of quality and safety. Everything that you do for safety will also help with security. And you can see that in the MISA guidelines, the most recent update for the MISA C guidelines, that was an extension for security, but it didn't say, okay, this is a part for security, that's a part for safety. No, the security part is the safety part and also the additional rules for security. Now, one sort of minor deviation from this guideline is that, well, if you have a crashing compiler, so your compiler doesn't compile your program, that is not a high quality compiler. However, it is a very safe compiler because it will not create incorrect code in your target component that you're developing. That's a bit of a distraction. Now, how safe are compilers? How good are compilers? Using our test suite. This is a report from just a standard test run with the GCC compiler, actually a C++ compiler, a GNU C++ compiler. It's a bit older than the latest version, but for the latest version, you wouldn't get many different outcomes from this. And what we see here is that actually, if you just take that compiler off the shelf, then our test run will show that there are 103 compile time issues that you have to look into. They don't have to be all very bad, and this is still a good compiler, and it can still be used for safety critical purposes, but you have to know about the deficiencies of the compiler. So compiler qualification for safety critical processes is mostly about knowing where the issues are in the compiler. And this compiler actually has a couple of runtime errors as well, where the results disagree with what the language standard describes. Now, compiler qualification, it may seem like a daunting process. It's a bit of the elephant in the room. You know that you have to, oh, I'm sorry, this is the wrong elephant. This is my African elephant. Let me try to fix that. There we go. This is my Indian elephant. Right, so compiler qualification, people are hesitant to do compiler qualification because it seems like a difficult process, even though they know that it's a good thing to do because, well, actually this compiler, it sits in the middle of your source code and your safety critical device. So if maybe you're developing obstacle avoidance software for a drone that has to deliver packages at people's homes, that's a safety critical application, and this compiler is compiling all of that code, that C source code for your machine. And so, yeah, you better make sure that this compiler does what it should do. So compiler qualification is it's not too difficult anymore. And fortunately, we see nowadays that more and more people are adopting this and are using compiler qualification in many different industries. So compiler qualification in particular for the automotive industry, I like the automotive standard because it is a very stepwise guide to qualification processes, in particular for this chapter, the confidence in the use of software tools. So that is a specific chapter that can be used for compiler qualification, and it provides the steps that you have to go through for the qualification process. So first you have the planning phase. You have to make an inventory of how you use the compiler. You have to evaluate the tool. How safety critical is that tool? What is the place of the tool, the role of the tool in the safety critical software development? And then you have a choice of a number of qualification methods. So actually the standard doesn't even say, well, you have to use this method or that method. You have a choice there. And based on that choice, you can then do a validation of the tool, and that will probably provide you with a number of imperfections in the tool where things are not quite all right, and then you can take mitigating actions. So you can describe, okay, this is what you have to do to safely use this tool. And finally, that wraps up in a documentation and review process. So the compiler qualification part is quite well understood. This is for the automotive standard, but for the other safety standard, functional safety standards for rail and industry in general, the process of ISO 26262 is quite usable as well. Now, what about libraries? Because libraries are a bit different from the compiler itself. They also are part of this package, the implementation of the C language or the implementation of the C++ language. A development kit comes together with a compiler and a library implementation. But these libraries have a bit of an in-between state because they are mostly invisible. You don't see them. You just program and they're automatically added to your program. They're also not your software, so you don't feel that kind of responsibility for that software. And if you look for library qualification in the functional safety standards, then it's not always so easy to understand what you have to do there. However, these libraries do go into your mission critical component, and it is very important that they do their jobs well. So you have to take a look at what libraries do, and also it is your responsibility that the libraries that you're using there, that they work well and that they are safe to use. Now, libraries are pretty hot these days, and that's a bit different from the past. In the past, especially in the automotive industry, we saw that manufacturers, they used C to program maybe the car control, the braking system, the steering system, but they didn't really use the standard library. They had their own libraries, that was their own software that could be qualified by themselves. And so they didn't use the libraries, or they tried to not use the libraries because, they had no control over that software. Now that is changing these days, and the reason is that it's driven by the opportunities that we see in 2D and 3D image processing, cars and also robots in this example, and medical imaging. They all work with much larger sensor information. So there's radar information, there's LiDAR information, there's cameras there, and that all needs to be processed. And there's huge image processing libraries that you may want to use. There's also machine learning libraries that you want to employ. And all of these libraries, they are themselves using this fundamental C++ standard library. So the container library in C++ is something you can't get around. That's something that as soon as you start using C++ for a bigger project, then you get to use this part of the C++ standard library, and that's very important to look at in more detail. So library qualification is more and more important to get right. Now, if we look into the functional safety industry standard, so that's the IEC 61508 standard. It has these three compliance routes for pre-existing software. Now, you actually have to look a little bit about where that is in the standard. So you have to go into part 3. So the standard consists of different parts. Well, part 3, and then there's clause 7.4.2.12. And that applies to pre-existing software. And that means that applies to libraries that you get from a third party. Now, there are 3 routes there. One is compliant development. So that is, you make sure that the development of this library is done right according to what's described elsewhere for software development. But that's not easy if you get the library included in your development kit. Second, proven in use. That's not a strong argument because these software is often updated, and even a small change can make a difference in the quality of something. And the third route, and that is the route that is preferred, and that is the assessment of non-compliant development. And then there's a next section, it's actually the next section in the document, that describes the requirements that you need to be able to assess software that was not developed according to the safety standard itself. And here are a number of steps. So I'm not going through all of the steps. There are more than 10 steps, I think. It's more than 10 requirements. But an important point is that many of these requirements, and I've listed 5 of them in the functional safety standard, they can be addressed by a requirement-based test suite. So if you have a requirement-based test suite for the standard C or standard C++ library, you can address many of the difficult requirements that are needed to assess this non-compliant development of your library. So one of them is that you need a detailed specification of the library itself and the requirements. I'll come back to that in a moment. Second is you need to verify the integration with the hardware. So you need to run the tests on the target hardware that you actually want to use. You need to do systematic verification that follows from point C, because for every requirement you need to have tests. You have to consider the failure mode. So if the library standard says, okay, this is out of range, this is out of domain for mathematical functions, for example, there is a defined behavior, and that you need to check that as well. And you need to verify as much as possible for the actual use case. Okay, requirement-based testing, I've told you about it for the industrial standard, but it's very similar for the other standards as well. So for the automotive standard, for the railway standard, you can also use this same process. Now, if you're thinking about the standard C library, what are the requirements that we have there? And now, fortunately, we have very good language standards. So the ISO C and C++ language definitions, they're very well-known documents, well-studied. And that's also an important reason why we can use C and C++ in safety-critical processes at all. Now, unfortunately, these standards they're not written as a list of requirements on the implementation. So I'm going to show you a little bit from the standard, and I'm going to say not so nice things about the standard, but that's not really a criticism of the standard, because the standard is very important, and we have to be very grateful that it is there, and it's a very important document to understand well. Now, this is an example from the ISO language specification, and it defines the function string copy. So this text is actually from the standard. So the third line, the green line, the string copy, what it does, string copy copies from array S2 and it copies into array S1, but it never copies more than n characters. So the third argument is n. It never copies more than n arguments. Now the third line, the green line, that says, well, if the array pointed by S2, so the string in S2, if that's shorter than n characters, then additional null characters will be added to the array. So that is a very clear requirement. It really says, okay, if this is the case, then that should happen. But the other lines are not so clear, because the second line, the yellow one, it says, well, if copying takes place between overlapping objects, and that means that the arrays S1 and S2 are not completely independent of each other, they may be partially overlapping or maybe completely, then the behavior is undefined. Now, undefined behavior is a sort of a scary issue in C, but it's really about a precondition of using the function. So it says here, not, okay, danger, behavior is undefined. It says, well, there's a precondition to using this function. Before you call this function, you have to make sure that S1 and S2 are not overlapping. That's not a requirement for the implementation of the library, but it's a requirement for the program. And the most curious sentence is the first one, because what the first one actually says is what the string copy function is supposed to do, but it says that the function copies not more than n characters. But it doesn't even say that it should copy as much as possible characters. So not more than n characters, that can be 0 characters. So if you follow this closely, this specification, then actually the string copy could just fill up string S1 with null characters, and that would be a correct implementation according to what it says here, because then it has not copied more than n characters from S2, and according to the third line here, you just fill up the rest with null characters, and that would be okay. Now, That's clearly not the intention of the specification and not clearly what is meant here, but it does illustrate that you have to be careful with turning the language standard, the language specification, into requirements. That's really a step that you have to do. It's not trivial to distill requirements from the language standard. And yeah, that's a lot of work. Let's talk a little bit about header files. So if you use the function isUpper, for example, you have to include the C-type.h header. The C standard also says that any function declared in a header, like isUpper, it may also be implemented as a function like macro. Now that's also important for library qualification, because it means that for the isUpper function that there are actually two implementations. One implementation is in the library, it's the precompiled binary, but the other part is the macro in the header. And you see that the orange-red part on the lower right side, that's the actual implementation of isUpper in the GNU C library. And that piece of code is actually compiled on your compiler when you develop your software. So you have to be careful about precompiled libraries, because some part of this library, the part in the header file, is actually going to be compiled on your target machine. In C++, templates, they take macros to the next level. So yeah, a large part of the C++ standard library is completely defined in the header files. And that goes for the container classes, for example. A lot of that is in the header files. It's not pre-compiled code. It is compiled when you compile your application. And that means that it's compiled for your configuration in particular. And that means that you cannot just rely on your vendor that says, okay, this is a precompiled library, you can use it. You have to make sure, you have to check for yourself that that pre-qualified library is suitable for your use case as well. And that might be all right, but you have to check it. You have to be aware of it. Okay, I'm getting to the end of my talk. So yeah, C compiler and C++ compiler and library qualification, it's not rocket science. The functional standards, they define processes that you can follow. If you have a requirements-based test suite, that will help you with a lot of the requirements that you have to fulfill for these processes. And you can even do it in-house. You don't have to get consultancy for that. You can do it in-house. And that gives you a lot of flexibility, because then you can vary the use case. You can upgrade the compiler when you get a new version. And that is a lot of advantage if you do it in-house. And anything that you do for safety also benefits security. We also know, of course, that security starts by just starting to think and using your brain. But anything you use for quality and safety is important for security. And when you do qualification, you always have to be aware of how the tool is configured. Is the configuration that you use the tool in your application, is that the same as what you have done the qualification for? And with these messages, I want to end my talk. So thank you very much for your attention. You can reach me at the email address that you see there, and you can reach us through the website, that's also mentioned there. And so thank you very much.